Let us look at the previous program again. So we were talking about scoping and we had talked about local variables. Okay. So as you can see, this float variable here this remains outside this block, and so if I use a printf here right at this point, it prints the value of this float variable, or you can see that the names are the same. And just outside these blocks, this is the printf for the float variable that remains outside. If you block out this float variable, you will see that the float variable outside of this inner block, that is this float variable, this is the one that is valid in this printf and that printf both. For example, if I run this, you can see the value of float var is 5.56. The value of float var is 5.56. Why is this? Because there are two float vars. There are two printfs to float vars, and in the absence of an inner float var, that is this one, the outer float var, this one, is valid here. The same does not apply to the inner float var. So if I block out this float var and liven up this one, there is now only one float var, but this is within this pair of braces, so which is within the inner block. Now there are two printf statements as usual, this one and this one. Now if I run it, see there is a problem. What is the problem? The problem is that the value of float var is float var, that float value is missing. Which one is giving the error? This one here, this particular printf here, this one. This one is giving the error. Why? Because in its scope there is no float var. So you can see the inner scope does not allow its variables to be seen outside as such. That is why this is called a local variable. It is local to a block. Once again, if I just deblock, that is unblock rather, the outer float var, the outer float var, that is this one here. If I just unblock this, and if I run this now, see, here we go. The first printf statement that appeared was the inner float var statement, and that gives us 37.000008, which is a bit weird because we have written 37.0006, so I don't know why it is taking it as 37.000008. Maybe some compiler issues. Nonetheless, it is very clear that the inner float var is being printed at the inner statement, this one here, and the outer float var printf statement appears below the inner block. So this is the value of the first float var, 5.56. Also, we have seen that there are two in this particular program, that there are two declarations of float var, one here and one here. And these two declarations, not being in the same scope, they are allowed. If, for example, a third float var were to appear, say for example here, I would write float var equals to say 8.907, let's say any arbitrary value. Now this is nonetheless a float var. But do you think it will work? The answer obviously is no, because this float var here and this float var here are within the same scope and they are clashing with each other. They've got the same name. So if they've got the same name, the compiler will be at loggerheads as to which float var it is going to address, whether it is the first one or the second one. There is a clash there. Because of this clash, the compiler is not going to be able to because of this lack of distinction, the compiler will not going to be able to compile this. And this is actually an error, that you should not declare two variables of the same name within the same scope. If you want to run it, immediately there is an error. Look at the error. Okay. Redefinition of float var 8.907. Previous definition of float var was here. Float var equals to 5.56. That means it is asking me to change the second float var or the first float var, one of the two, by its name, because identically named variables are not allowed at all. Okay, so that means this will have to go. If I unblock this, once again it is running. Beg your pardon. So if I unblock this is once again running. See? So this is how the scoping of local variables work. What are these local variables? I've mentioned here local variables. What are these? Well, simply speaking, these are called local variables or auto variables. Okay, local variables or auto variables. Why are they called so? As you've seen, when I have declared the variable, the scoping of the variable was automatically set to the block in which the variable appears. By block, I repeat myself, I mean this pair of braces. Pair of braces are there. A pair of braces form a block. In C, a pair of braces for this. So this is the void main brace close, corresponding to the void main brace open. And this is the main block. This is the inner block of the main. So in C, these open brace and closed brace pair form a block. There can be outer blocks. Blocks can have blocks within blocks. Blocks can be enclosed within other blocks. So blocks enclosing blocks are called outer blocks, and blocks within blocks are called inner blocks, and two blocks that are not within each other are called external blocks to each other. They're external blocks. Here there are no external blocks because void main is the main function block, and within which there is this inner block here. I can also have another block, let's say just this, open brace and close brace there. This is another block, and it's called, and this block, this particular pair of braces form this block, which is now an empty block. There's nothing in there. This is an empty block, and it is absolutely allowed to have an empty block. Why would you have an empty block? That is one other question. Well, you should not have any empty blocks in your program, but it is allowed. Let's run it. no problems at all. Obviously, nothing happens inside the empty block. We don't see any results or whatever. We don't see anything like that. But it is another block nonetheless. And this empty block, okay, is external to the first inner block because they are not within each other, they are outside of each other. But these two blocks are within the same scope. These two blocks are actually within the same scope. Same scope as what? Well, because they are both within the main functions block. So that is exactly why these two blocks are within the same scope, the scope of the main function. In another attempt, what we'll do is we will create a block around the two printfs here. Now you can see, let us say we call it the third block. So let's say we call it the third block. So this is the empty block, this is the third block. And inside the third block now are the printf statements. It is absolutely allowed to have a program written like this. This will help you in arranging your code. Now, in this case, this arrangement is not necessary. I'm not saying it does not make sense. Obviously, you're putting it in blocks, that's fine. As long as it is within the scope of main, that is okay. You see, if you run it, there we are. The same result or output is received back, the same. Now, there is obviously no reason for the third block or the empty block. That is true. I have just written them to show you how the empty block or the third block look, or how blocking or rather creating blocks can be done at ease in C. They are really not important as such, given the program that we have here. But in many cases, when we're writing big programs, we would like to do some coding later on. So we can use blocks, empty blocks, so that we can put in some values later on. For example, if I wanted to have a function which returns, say, nothing, so I put it as a void function. And if I name it function, say 1, fn1, that's function 1, and open braces and close braces, so it does not take anything also. And if I wanted to just give a, now I have not decided as yet what I want to do with this function. I don't want to speculate also what I can do. Maybe later on, when I am very certain that I want to run this program with the function 1, I can come back and write it. So I will just write the function above main here, like this, function 1. This function at this moment, because it's a void function, it doesn't return anything. It returns an empty value or whatever, however way you take it. It's not some value that we can use anywhere, so we don't have to worry about returning a particular integer or float or character, whatever. We don't have to worry about that. So it is just a function like this. Now, is there any sense of writing a function like this? The answer obviously is no, if you're not using it. But sometimes what happens is people will write a function like this because later on they want to come back and they want to write some code. If you call this fn1 from anywhere within main, let's say here, fn, open bracket, close bracket, remember this is the function call. If you write it like this here, okay, and if you run it, let's say undefined reference to fn, obviously because I've written the name wrong, so let's just get it right. Okay, fn1 like that. If you run it, it just says nothing because fn1 does nothing. However, if I left it out, then also it would have the same result. But I could do this, okay, not to unnecessarily prolong it or rather lengthen my program, but just so that later on I might come back and use this function. In these cases, what do developers do to indicate that they have not written anything? Remember, this is a small program. In large software products, when you're developing large software products, there may be several uses of keeping a function empty to which you will come back later on. But then you will not remember how many functions you have. So we initiate it like this, or rather we write a code like this here, say printf. Okay, let's give it the name, so fn1 no useful code. Alright, whatever written, see the part in green, fn1 no useful code. What does that mean? That means that, let us say it's a big program and I meant to write something in fn1, but I've forgotten to write in fn1, but I've called fn1 here anyway. So if I run this, it will show me fn1 no useful code here. Okay, this part here, fn1 no useful code. What does it actually tell me? That fn1 does not do anything useful whatsoever. fn1, either I have left it like that, like for example here I am trying to teach you about writing empty blocks and empty functions, so I've just left it like that, or which is more important, that I may have left fn1 out by mistake. I may have left fn1 out by mistake. Now you can realize that will be a problem, because when I am trying to use fn1 in some program and I have not used the code, it will give me no results at all. Just to know that this is what I've actually done, just to remind myself of this, I've just written no useful code. This is a normal programming practice with software engineers. This is how we do it. Okay. So rather than keeping a function just empty, we write something like this. Okay. so that there is no confusion regarding which function is useful and which function is not. Similarly, when we are writing an empty block, okay, that is absolutely okay with the compiler, that is absolutely okay with the compilation process, but we should not do this. So similarly here, if I just leave it like that and when I run the program, nothing will happen. Nothing will happen. There is obviously no output, so I can't see. So that is why I would like to write here say a printf statement where I would write warning block empty. And I would put this in a new line. Enter this within a new line. So \n and \n. Now when I run this, okay, it'll give me warning block empty. That means when I'm running the program, when I'm testing a program, I will run it. The first thing I will do is not look at the code. First thing I will do is run the program and see if I have got the code correctly. Immediately I will be issued a warning because I put a printf statement there, warning block empty. That means either you delete the block or okay, or just put something useful in there. Right. So similarly, here I will maybe want to put another float with a different value, say 8.906 semicolon. Remember, the semicolons are very useful. They're very very important because that actually closes, that actually closes the statement. That's a statement separator or a statement terminator, whichever way you look at it. So you need the semicolons. This is a very important thing, the semicolons, okay? If you don't put a semicolon, it is an error. Anyways, so new line, then a conversion character, as we have seen before, for float, and we write out let us say here we write out both the inner and the outer float values. If you try to do that, what will happen? If I just, okay, you won't be able to do it because it will print two versions of the float value. Now let's say this float value I'm going to print twice. So without the use of loops, I can do it like this. Now here two values will appear. So this is something to tell you about the printf statement also. Here two values will appear and I'll have to name which values should appear. Float var, comma, float var. That means, what does it actually mean? In the first position of %f, first float var will appear. Second position of %f, the first float var. That means in this case, the first float var is a float var that is nearest to it. And what is nearest to it? What is actually nearest to it is the floatware inside the so-called empty block. We will not call it an empty block anymore. We call it a second block. Because it is not an empty block anymore. We call it a second block. Alright. So floatware 8.906 printf floatware. That means its nearest floatware is this floatware here within the second block. The second block floatware is within it. Okay. This floatware here. So it will be printing this floatware twice. And let's run it. There you go. 8.906.000, 8.906.000, and because it is taking 6 decimal places, it is putting 3 zeros at the end. If you wanted to trim those zeros, now here is something. If you wanted to trim those zeros, how would you do that? Well, let us copy this printf statement and look at a bit of formatting. Let's copy this and let's paste it once and let's paste it twice. Now, here instead of F, I will do %G. And here instead of F, I will do %E. So, sorry, not here. Here I'll do %E. There I'll do N. Now I will just remove the new lines at the end of these two statements because the new lines at the start anyway. See what happens. So first of all, I've printed the same 2 copies. I've printed of floatware 8.906. One I've given with %F, second one with %G, third one with %E I'm printing. So let's see what happens. Look at this. So when you see the first one comes out as 8.906.000. There. This is the first one that we have done here. This position here. Okay. This is 8.906.000, 8.906.000, that is %F. It is giving 3 zeros at the end because of the absence of anything else there, but there are 6 decimal places. When I use %G, this is this one here, that is %G. And what is this %G? It trims the empty zeros. So that means you know that after the decimal point, the zeros at the right hand side, they are of no value at all. So that is why %G just trims all the extra zeros from there. So 8.906. And this one, the E something, is the 10 base format. Okay. So it's like what you have in the case of a calculator. You have this. Okay. When you have this, in case of a calculator, this is what you have. This is produced as a result of, this is produced in the form of something and 10 to the power of something. That is written as E to the power of something. Okay. This is what it is. I mean, if we just changed this value from 8.906 to, let us say, 89.906, what would happen here? That will make you clear. Make it clear to you. See, there. Look at the E now. So this is 89.905.998, 89.906, so on and so forth. Why it is 905.998 is because it is approximating the value. Okay. Whenever it is left with a value at the end, it will make this approximation because of the way floating point numbers are represented. When it is interpreted, some compilers like this one, for example, will interpret it like this. There's nothing wrong with that, so don't be too much worried about it with this value. Now this value is obviously the %G value. Okay, 906, and this one on the other hand is a percent E value. As you can see, 89.906 is written as 8.9906 10 to the power of 1. E plus 01 is 10 to the power of 1. So this is the way you are printing the same thing. You are printing it like this. But remember something. Remember very carefully. You cannot use percent G and percent E with scanf. This is a formatted output only. So you can use it only with printf. Okay. So that means that these things that we did here, percent f, percent g, percent d, printing the same thing again and again like this, only works for printf. When you are using scanf, it will only take percent f for float, only percent f for float. So as I said here, the following cannot be used with scanf. Now, continuing with the ideas of scoping, what will happen if you want to have a variable that is visible across everything? Okay. For example, let us now declare what is called a global variable. Why is it called global? Because it is visible, it is declared outside of any function block, main, fn1, whatever. It is declared outside of any one of those. Okay. And because it is declared outside of it, right at the top it is declared. Okay. Because the compiler needs to know it. So right at the top it is declared. Once it has been declared, it is visible throughout the particular file. So float var, okay, now inside fn1, to do something very peculiar, I will give it a local value of float var, let's say 6.98. Note that I have not used float var, rather I have not declared float var inside fn1. Okay, so for example, if I block out this float var here, try to run it, immediately there is a problem. Because float var, I have tried to use float var, but I have not declared it. I have not declared float var as anything. What is float var? Is it a variable? Is it a function? What type of function? What type of variable? I have not declared anything here. That is why it is going to be a problem here. If I remove this, if I unblock this global float var, immediately it works. The value of float var is so basically. So hello fn1 no useful code is still there. Hang on just a sec. I have not changed the printf, I beg your pardon. So I have to do that. If I just do a new line here, a new line, and then a percent f, and then if I write, sorry, I didn't do that, float var, okay. So before that I will write this global float var, okay. Now run it. See, global float var 6.98000. Right? We give it the value 6.98, so it's giving us 6.980000. Right? How did we do that? Well, why did not it give us an error this time? Well, the reason being that it is a global float var. This float var here is a global float var, and this is what is used here. Similarly, you will be surprised to note that, okay, now you see in all these cases inside the main, all the values of float vars are taken locally. All the local float vars are active. You see, first one, this one here, this printing is the first inner block float var. Okay, this one here is the third float var, third in block float var. This is the second block float var. Or rather, this is the second block float var. This is the outer block. That is the main block float var. So all of these float vars are there. These are all local. You can see this float var. This is taken as this, the third block float var. Because there was no other declaration of float var, the main float var was taken. Okay. Let us look at the second float var which appears here. That is the first inner block float var. This is printed here. The second inner block float var is this one. This is printed here and here and here. The third block float var, well, the third block does not have a float var. So, as we had seen, it is taking the main float var, which is this. And in all of these, the global version of float var, the local version of float var is taken. Now, let us just simply delete so what we have done in the mains float var, we have deleted float. That means we have deleted the declaration card. We are only as if we are assigning this. And here also we are assigning the value only. This is not a declaration. This is no more a declaration, just an assignment. So we are assigning the value here and here. Which float var do you think we are using? Well, simply we are using the global float var here. Okay. Now see what happens. Value of float var is 37.00. The next one is 89.905, etc. Then again 37.000. Why do you think it happened? Very simple. You see, here there is a declaration of float var which we have not erased. Here there is a declaration of float var which is not erased. So for the second block, second inner block, this declaration is valid, this one here. But in the main block and in the second, in the first inner block, there is no declaration of float var. So basically, these are nothing but use of the global float var. This one is also use of the global float var, and Okay, this one, so what does it do? This uses the global floatware, okay, which was last assigned in the first inner block. That means this will be also using the global floatware, but because it was reassigned to 37.000006, okay, so instead of 5.56 here, we are using the value this, because this is just a reassignment. Okay, if you write x equals to 5, then before printing x equals to 5 you write x equals to 6, then obviously you will not get x equals to 5, you will get x equals to 6. The entire thing changes if I just take this one here and cut it, and what I will do is right at the end here I will paste it. So what am I doing? I'm using, okay, so these are the local variables. So auto variables I'm using, these are using the global variables. Basically we are printing global floatware here, and here we are reassigning, so we reassigning rather the global floatware. Okay, so we are printing the global floatware here. Now we are reassigning the global floatware to 37.006. Here the local variables or auto variables are going to be working, but in the third block, okay, this will be, so it will last assigned in the first inner blocks. Okay, so what will be the last assignment of the global floatware? The global floatware is 37.06 here. And so what happens is, if you write now, the first value of floatware appears as 5.56 because that is how it is reassigned in main. Okay. The second value of the local floatware is here. We are not talking about that. Global floatware second value is 37 because that is how it has been reassigned. And this one here is an assignment right from the function fn1. Okay, because in HFN1 this is getting reassigned here. So when we are calling FN1 here, in FN1 it is getting reassigned to 6.98, and as we have seen before that this is how it is appearing in this line. Okay, that it is assigning as a global float back 6.98. Now what will happen if I use, see, another printf statement, and this time we have come back from FN1 and we are inside main, but we want to print the float var again. Okay, so we want to print the float var again, so we put a new line, then we put a %f. Okay, then we write float var. So we have run FN1. In FN1, what has happened? In FN1, the float var, that is the global float var, was assigned a value 6.98, and we had printed global float var is 6.98, and we have come back from FN1 back to main. Now here we are writing right at the where we have come back after FN1, the call, this is the call to the function FN1. FN1 will execute, then the control will come back to this point here. At this point, what have we written? Printf, new line, %f, then f float var. Now what float var will we actually take? Will it take the last assigned float var, global float var, that is this, that is, will it print 37.000006, or will it actually print 6.98? Will it print 37.0006? Because 37.0006 was the last assigned value of the global float var in main. Will it do that, or will it actually print the value assigned in FN1? FN1 was called here. So just before this, the global float var in FN1, it was changed to 6.98. Will that changed value be appearing here? Well, let's see. 6.98. See this. Look at this here. 6.98. Okay. So see, this is the one that was assigned in FN1. This is the one that appears in main after it has been reassigned in FN1. So this is what I want to talk to you about, global variables, that they are visible across boundaries. That means you can assign them, reassign them across boundaries, whether it's in main, whether it's another function, whether it's an inner block or an outer block. In the absence of a local definition of float var or local declaration of float var, the global float var will be taken, and it will be this one float var, which is the global float var, until and unless, like we have done here, right here, okay, this part, we have used this is the second inner block float var, and the second inner block float var is local variable. Okay, second inner block float var is actually a local variable. This one here, it's actually a local variable. This is as we know, it's a local definition of float var. So that is why the global values are not appearing here. Only the local values are appearing. So what have we learned from here? That in the two types of variables that we've seen, the global and the local ones, the global ones are declared right at the start, at the top, which is here. And once we have declared it, and this is declared outside of any function, just at the start of the program, and this is visible across the program, and we can change it in any function whatsoever, and the changes will reflect. Unless and until a local variable, that is a variable that is particular to a particular block, that is local to a particular block, appears with the same name, and in this case inside that block, like the second block here, inside that block, only the local value will be accepted, not the global one.